Okay, we're looking at Module 3, Section 2 right now. And in Module 3, Section 2, we're talking about operations on polynomials. So we're going to see adding, subtracting, and multiplication. Not until Section 3 are we going to focus on division. But in Section 2, we're grouping addition, subtraction, multiplication together. So let's start with adding and subtracting polynomials. And when we add and subtract polynomials, we want to focus on what's called like terms. So a quick definition for like terms, probably something you've heard plenty before in math. They are terms whose variables and the exponents are the same. So x squared terms or x to the third terms, terms whose variables and exponents are the same. Combining like terms just means we're either going to add or subtract, put together these multiple like terms into one term. So you're going to put together, either with addition or subtraction, multiple terms into one. So then that leads us to adding polynomials. So looking at what we did in Section 1 with polynomials and adding them, we're going to be combining like terms using addition. Simple as that. Just combining like terms using addition when we add polynomials. We're going to look at a few examples of that in just a bit. The next thing is subtracting polynomials. Pretty much the same definition, combining like terms, but we're going to be using subtraction. And the method, I'm going to put this in parentheses, the method you're going to see me do is distributing the subtraction or distributing the negative, then combining like terms. And I'm going to refer back to this definition in just a second when we get to some examples, but that's the method you're going to see me use, is distributing the negative first, then combining like terms. Okay, let's look at some examples here. Looking at this first example, perform the following operations. So we have two polynomials with addition. This is adding two polynomials together. Let me erase this, because when we add two polynomials, we just want to combine like terms, going back to our definition. So the s squared terms get added or combined together. 2s squareds plus 4s squareds give me 6 of them, so 6x squared. I have negative 3s and positive 2s, so that's negative 1s, or just negative s. And then I have 2 plus negative 7, negative 5. So not too bad. Let's look at the other example here. If I can zoom in and focus on that one. I'm adding again two polynomials. So I have, to start, 14x to the fourth, and then over here on this side, there is no x to the fourth. So I don't need to combine it with anything, and I'm just going to write 14x to the fourth. There was nothing to combine x to the fourth with, which is fine. Next is the x cubed. I have negative 6, and I have 1, so that's negative 5. Next would be the x squareds. 1 and a negative 5, that's negative 4. There's no x term. Don't need to write anything there. Negative 6, positive 1 will give me negative 5. Now let's look at these subtraction questions. So we have a polynomial subtracted by another polynomial. What we need to do here, if I go back to my method, I said I'm going to distribute the negative and then combine. So probably the easiest way to do this, especially with these longer polynomials, is to make sure that every term behind this negative gets distributed. So what's going to happen, if I write this out, I'll have, and because I'm distributing this, I don't necessarily need the parentheses anymore. I'll have 2a cubed. Oh, my pen's not working so well right now. Let me try to rewrite that. 3 minus 5a minus 7. And distributing that negative, it now changes all these signs. So that would be like my subtraction. Minus a cubed plus 2a squared minus 3a plus 7. After I distribute that negative, I'm going to type this out because my handwriting's horrible right now, combine like terms from here. So I'm going to combine like terms, which means I can take this a cubed and this a cubed to give me 1a cubed. I can do, I have 1a squared here, so I'll just put that one down. So plus the 2a squared. I have, let's see, a negative 5a and a negative 3a minus 8a. And then I have negative 7 plus 7. That gives me 0, which means this is what I'm left with. So similar here, I'm going to go ahead and distribute the negative. I can say I have 7x to the 4th minus 8x squared plus x, and then that's now minus 9x to the 4th minus x squared and plus 18. Again, after you distribute the negative, our method is just to combine like terms. So combining like terms, 7x to the 4th minus 9x to the 4th are the two I have to combine. So that gives me negative 2x to the 4th. I have x squareds that are next, negative 8 and negative x squared, negative 9x squared. X doesn't get combined with anything. And then this 18 is out there by itself, plus 18. So that was addition, subtraction. The rest we're going to focus on multiplication. So with multiplication of polynomials, a few things I want you to recall. First off, I want to define within a polynomial, what's a monomial? Well, a monomial is a polynomial with one term. We also have, you've probably heard of a binomial. That would be a polynomial with two terms. And then another popular one is a trinomial. That's a polynomial with three terms. So what I want you to recall from this is specifically multiplying monomials, multiplying one term by one term. So I have this term times this term. When we do that, we're going to go ahead and multiply the numbers first. 7 times negative 4 is negative 28. And then y squared times y to the 5th. Well, that gives me y to the 7th. One way you can think of that is if I have y squared, that's y times y. And then I'm multiplying y to the 5th. How many powers of y do I have? Well, I have 7 different powers of y. So essentially what we're doing is we're adding the exponents, the 2 and the 5, to get a power of 7. So looking at our next example, multiplying monomials, it looks like the only coefficient out in front is 10. So I know there's a 10. Then I need to multiply these a's, negative a squared, and then positive a. Well, it's definitely going to make it a negative value. So our overall monomial is going to be negative. A squared and then a to the first. There's always going to be a first power there with the variable if nothing else, no other exponent is written. So that would be a to the third. Then I have, let's see, b cubed and b to the first. That gives me b to the fourth. Finally, c to the first times c to the 12th gives me c to the 13th. So let's take it a step further now and multiply a monomial, remember that's just one term, times a polynomial. So one term times multiple terms. First example, we have a monomial times a binomial. We have 4x times 3x minus 2. And we want to distribute, in this example, distribute the monomial. So we're going to take the 4x times 3x and the 4x times negative 2. So with our distribution property, 4x times 3x is 12x squared. 4 times 3 is 12. X times x is x squared. Then we take the 4x times the negative 2, and you get negative 8x. These two aren't like terms. One's x squared, and one is just x. So that's how I know I'm simplified. Next example to the right, we want to distribute that negative y. So negative y times 4y squared. Well, I know that's going to be negative 4. Y times y squared is y to the third power. Then negative y times 2y. I know that's going to be negative 2. Y times y is y squared. Negative y times negative 3. It's now going to be a positive 3y. No other like terms. I know that's simplified. Last example, negative ab squared. We're going to distribute that to the 4a squared. Well, I know the number is going to be negative 4. Then we have a times a cubed, and then we have that b squared. So our first term is negative 4, a to the fourth, b squared. Let's distribute that to the next term. Positive 2. A and a is a squared. B squared and b is b to the third power. Distribute that to the last term. Negative. You'll have an a and then a b squared times b squared is b to the fourth power. So we want to look. There's no like terms. That means this is simplified, and we're good. So let's take this one step further and say, what happens when you multiply any two polynomials? Well, with any two polynomials, we're still using the distributive property. So we're still going to, that looks more like a p. Let me change that. Still going to distribute. It just might be more involved now than it was in the last examples. So when we distribute, we want everything to be multiplied from one polynomial to the other. So that means this 2p gets multiplied by 4p and gets multiplied by 1. So let's do that first. 2p times 4p gives me 8p squared. 2p times 1 gives me positive 2p. Now we need this 3 to be multiplied by 4p and by 1. That gives me 12p plus 3 times 1 is 3. Everything is now distributed, so we can look to combine like terms if possible, and we can with 2p and 12p. Those two combine, right? So we have 8p squared. 2 and 12 give me 14p plus 3. Okay, in this next example, we still have to multiply everything from the first polynomial and distribute it into the second. So I'm going to start with a squared, and I'm going to multiply it by a and by 2. A squared times a is a cubed. A squared times 2 plus 2a squared. Now I need to multiply 3a times both terms. 3a times a plus 3a squared, 3a times 2 plus 6a. Last, I need to multiply the negative 4. I'll use green here so you can see it better. Negative 4 times a, negative 4 times 2. So negative 4 times a minus 4a, negative 4 times 2 minus 8. And again, looking to combine anything to simplify. So combining a squareds, and then we can also combine these a's together. So I have, in descending order, I'll put a cubed up top. Then I have this a squared and this a squared. That gives me 5a squared. Combining the a's together, that should be 2a's and then minus 8. Last, I have a little bit longer one. It's 3 terms times 4 terms. So we're going to need a little bit of room here and make sure everything gets aligned straight. I have to start with x squared. So I'm distributing this x squared to all 4 terms. Let's start with x squared times 2x cubed. That'll give me 2x to the 5th. X squared times negative 4x squared. Negative 4x to the 4th. Keep going, x squared times negative 4x, negative 4x cubed. Lastly, x squared times 2 plus 2x squared. Okay, that's 1 done. I'm going to erase these because I'm going to end up overwriting myself a bunch. So to make it a little more clean, let's do the negative 4x now. So negative 4x times all of those. Negative 4x times 2x cubed, negative 8x to the 4th. Negative 4x times negative 4x squared, plus 16x cubed. Negative 4x times negative 4x, that would be plus 16x squared. Negative 4x times positive 2, negative 8x. Another one down, so we have just the 3 left to distribute. I'm going to go ahead and zoom out just a little bit so I have more room on my page to write these last few terms. So this 3 now gets multiplied by the 2x cubed plus 6x cubed. 3 times negative 4x squared minus 12x squared. 3 times negative 4x minus 12x. 3 times 2 plus 6. Zoom out a bit more. Just barely fits on the page. Plus 6. So that's all of it distributed. Definitely a lot of multiplication there. Now it's a combined like term game. So we have to see what like terms do we have, how can we simplify this? Well, I just see 1x to the 5th here, one value of x to the 5th. So, and actually let me circle that a little better so you can keep the negative out in front. 2x to the 5th is all I have here. So that can be written down. Next we're looking for x to the 4th. Any x to the 4th, there's a negative 4x to the 4th, there's an x to the 4th, and I think that's it. So negative 4 and negative 8 means negative 12x to the 4th. Now we're on the hunt for x cubed. X cubed. There's 1. There's 1. There's 1. Negative 4. 16. So that gives me 12. And then 6 gives me 18 x cubes. Now we're looking at x squareds. So here, I'll box the x squareds. Here's an x squared. Here's an x squared. here's an x squared. So I have 2 and 16, that gives me 18. 18 and negative 12, I'm left with 6x squared. A few x's, there's one, so negative 8, negative 12, minus 20x. And lastly, there's just a 6 all by itself right here. Right here. So plus 6. And we're good. Quite a long polynomial there. 5th degree, right? 5th degree polynomial. And moving on to the last page here, there is a shortcut method to multiplying two binomials, and I'm sure you've heard this before, called the FOIL method, the foiling method. FOIL standing for first, outer, inner, and last. FOIL, those first letters there. Essentially it means multiply the first terms, multiply the outer terms, multiply the inner terms, multiply the last terms. And this only works with two binomials. So two things multiplied together that have two terms in them each. Here's an example. I have a binomial here, and I have a binomial here. So I can use the FOIL method to think about how I'm going to distribute this and to organize my work. That's just a popular way to organize it. So using that FOIL method, if I put f here for, what are the first terms multiplied together? Well, what are these two terms multiplied together? That gives me 6x squared. O would be the outer. 2x times negative 7, negative 14x. I would be those inner terms, plus 15x. And then the last terms would be L for last. So minus 35. A lot of times you'll get common or like terms you can combine. So I have those two like terms, 6x squared, that gives me plus x minus 35. So that's just a good way to keep things organized when it's a binomial times a binomial. And we can do it again on this example. If I write out FOIL here, I can stay organized by multiplying the first terms first. X squared. Then the outer terms for O. 5x. Inner terms, minus 7x. Last terms, minus 35. Combine like terms again. These two middle terms combine to give me x squared minus 2x minus 35. A few more examples of these binomials. Let's look at this next one. Again, if I want to use that FOIL method, you don't have to write this out, but sometimes it helps. 4x and x gives me 4x squared. 4x times 6 plus 24x. Negative 3 and x minus 3x. Negative 3 and 6 minus 18. Again, these middle two terms combine. It's pretty common when you multiply binomials. Not always, but it's pretty common that the middle ones combine. So 4x squared plus 21x minus 18. In our last example of these binomial multiplications, I'm going to go ahead and use the FOIL method again. That's supposed to be an I, L. So our first terms, 6x times 2x, 12x squared. Outer, 6x times negative y. So we'll just put negative 6xy. Inner, 5y times 2x plus 10xy. Last, 5y times negative y minus 5y squared. Go ahead and combine like terms. Well, I see an xy here, and I see an xy here. So that means I have 12x squared, negative 6xy's, and 10xy's give me 4xy's. So I'm combining that to give me 4 minus 5y squared. And there we go. And the last thing I want to talk about in section 2 is binomials raised to powers. So something raised to a power. We need to, whenever we see a binomial raised to a power, we want to expand the binomial first. Expand the binomial first. Then we can distribute. So we have to expand the binomial first. It's really important, and don't write this one down because I'm going to show you what's common but what isn't the same thing. It's really important that we don't distribute this squared. If I distributed that squared, I would get 2x squared and then negative 1 squared is plus 1. I want you to see that that's not the same thing. If I take something squared, that's the same thing as, because it's not this. It is the same thing as saying, I'm taking 2x minus 1 and I'm going to multiply it by itself one time, or 2 times, excuse me, because it's squared. I'm going to take 2x minus 1 times 2x minus 1, and I can distribute this out using that FOIL method. So I can say, well, 2x times 2x, 4x squared. The outer is minus 2x. The inner is also minus 2x. The last, well, negative 1 times negative 1 is plus 1. Combine my like terms. 4x squared minus 4x plus 1. And we can see how that's definitely different than what distributing the 2 would do, distributing that squared value. So this is what we want. We want to expand the binomial. Using that pattern, let's look at 2x minus 1 raised to the third power. That means I'm taking 2x minus 1 3 times. What we need to do here is focus on just 2 of them at first. Just focus on multiplying 2 of them. And luckily we just did that math. We just multiplied 2x minus 1 times 2x minus 1, and we got, let me highlight it for you, we got this guy right here. So what I'm going to do is say, whoops, go back to my pen, see last problem for this. See last problem. So I have in those brackets what happens when you multiply 2x minus 1 times 2x minus 1. We still have to bring down this one that we haven't multiplied out yet. Now this turns into a problem like we saw previously in our notes, where we need to make sure everything gets distributed from one polynomial to the next. So let's go ahead and do that and say 4x squared times 2x gives me 8x cubed. 4x squared times negative 1 gives me negative 4x squared. I'll multiply the negative 4x times 2 minus 8x squared. Multiply the negative 4x times negative 1 plus 4x. Now I'm going to multiply this 1. The last thing I'll do is say 1 times 2x, 1 times negative 1. Well, that's easy. It doesn't change those values at all. 2x and then minus 1. Combine like terms, x squared and x squared. I also have x and x. So I'm going to go ahead and combine those as I write my next step. 8x cubed. The x squared should give me negative 12x squared. The x's should give me plus 8x, and then I have that minus 1 at the end. So a little bit more work, but make sure to expand the binomial before we distribute.